Hey guys, welcome to the next video in the synthesis series. So this one we're going to be just going over another example of how we can approach these questions. We'll go through it step by step, okay? And this may be something you could see on a test or just in general as you're studying. And so yeah, I just wanted to go through this specific example. And so I gave you guys a toolbox here, and you can see that I still shaded out this one reaction here that you haven't learned. You'll get to it later on. I don't want to show it to you guys to confuse you yet. That's why any synthesis involving this reaction I've omitted. And yeah, I just don't even want to show it to you guys so that you don't even get the thought of how to use this. Okay? And so let's just run through this problem because I think this is a pretty good problem. And yeah, and it tests a bunch of different things that you learned. Okay? And so let's look at our molecule here. You can see that it's not just an alkene or an alkane, right, which is something you might have already kind of been accustomed to. We can see that we have this OCH3 group on here, right over there, this ether group, and we have a Br, okay? And so now our synthesis is actually a little bit tricky, right? An OCH3 and a Br on the molecule, you might not have seen that yet, but it uses everything you guys have learned so far, so don't freak out. Okay, the worst thing you can do in the synthesis is start to freak out. Okay, and so just analyze what you have so far. You can see that our OCH3 is on a carbon more substituted than our Br. Okay, and now what I want you guys to do, essentially, is if you want, you can pause the video. If you don't want to, feel free not to. But think to some of the reactions you guys have learned. Okay, do not limit yourself strictly to the synthesis toolbox. Okay, that is a big mistake. In synthesis, you can use any of the reactions you guys have learned, like alkene reactions, any of the future reactions you'll learn in Orgo. Those are all fair game for synthesis, okay? And so hopefully when I said the alkene reactions, that may have jogged your memory a bit of how we could have become this molecule, all right? Because let's remember, this is the product, and they want us to synthesize this. They want us to synthesize this compound, right? And so we need to essentially work backwards. Okay. Oh, and so yeah, and I should have mentioned that they wanted it in 4 carbons or less. Okay. Sometimes they can change the number, but and so yeah, and so we need to think about an alkene reaction, right? That's the only kind of reaction you guys know that can create a bromine and this OCH3 on the same compound. And so if you want, pause the video and try to figure out the first step going backwards that can generate the structure. If not, I'm about to show you guys what it is right now. Okay, so we're going to write Br2 over HOCH3. Okay, and we're going to end with this alkene. Okay, now why did I know that it was going to be this? Okay, well, my method of synthesis, if you guys have seen the videos, is once I go back one step, I go forward again just to make sure it works. All right, you don't want to lose points in the synthesis. Okay, it's not. There's a lot of things that you can easily avoid losing points on, and if the reason you lose points is because you didn't check, that's not going to really feel that great afterwards. Okay, and so if you remember, for this Br2 reactant, we end up with this sort of intermediate, right? Br, right? And now we also had a Br minus that we kick off because we had Br, right? And we have our HOCH3. Now remember, the HOCH3 is a solvent, and it attacks the most substituted carbon, right? Giving us this structure. Right? And then obviously we'd have to depronate it. And if I didn't mention it before, you could use either Br minus or HOCH3 if I'm talking about like a mechanism question. Either would be okay. if you want, just to be more correct though, I'm going to pick the solvent just because Br minus is almost non-basic. It's got like, I think, a pKa of -8, whereas HOCH3 has a pKa of 16, so it's more basic, but you don't have to worry about that. And yeah, we would deprotonate, giving us our original, our product that they gave us right there. Okay? And so this definitely works. Now remember, this intermediate does not create any carbocations. There's no possibility of a shift. And if you end up in a synthesis using a reaction that can lead to a shift, be extremely careful. Because if when you're checking by going forward and you see, oh, I could have shifted and that wouldn't have resulted in my compound that they gave you, you might have done something wrong. Okay? And so we went one step back, great. We have this alkene. Now, what do? Well, you can look at your toolbox. We have this alkene, and when we can go backwards with OH minus, right? OH minus, and we can put a Br on one of our carbons. Now, which carbon? Well, we could have put it here, or here. Okay? And so yeah, we could have put it on either of them. Which one is going to be the one that you want to pick? Well, let's do this going forward. The OH minus can form the double bond if we're looking at the left molecule, either on this carbon or on this carbon, right? It's going to want to form the double bond to the left here because it's more substituted, okay? And so that can definitely work. This red double bond, if I erase the blue one actually, here will not form because that is not the more substituted one. Looking at our molecule on the right, we could either form a double bond here, oh, right there, or erasing the blue one, we could have formed it right there. Now it would form the blue one. Oh, let me just change the color. It would form the blue one just because that is the more substituted one. And same for the one on over here. We would get the blue one. If we erase the Br, that's what our final structure would look like. So you could have picked either of those positions. Okay. Now I'm going to pick this position right over here for my Br. Okay. The reason I'm going to pick that position is because it allows me to cut more carbons, because inevitably we're going to have an OH and we're going to have that cut step, right? And so you want to make it as easy as possible for yourself and do a synthesis in as few steps as possible, right? Because no one wants to sit there doing a 20-step synthesis, okay? And so we have our Br here. Now what's the next step? Okay, in our toolbox it says HBr. We just put an OH going back. Okay, cool. And now we have our cut step. Okay, now again, the easiest way to approach this is look at the carbons connected to the carbon of the OH. Alright, so there's that one, and there's that one. And all you need to do is cut that bond, right? We just cut that bond right there, one of them. And so we have a choice. We could either cut this way, or I could cut this way, right? How exactly are you going to want to cut it, right? Well, that depends on how many carbons you need to get down. We need to get it down to 4 or less. And so let's just do both ways so we can evaluate both of them, right? Remember, on synthesis questions and tests, there are definitely more ways than one to solve them. And so let's do the blue first. Actually, let's do the red. So I'm cutting right down here. And so actually let's number first. That's always a good habit to get into, even before I cut. So 1, 2, change that, 1, 2, 3, 4, 5, 6, 7, Always a good habit to get into. Now, cut between 2 and 4 and redraw your carbons. Don't even consider the whole lithium and the carbonyl yet. Don't worry about that until you have everything numbered. Okay? Alright, and now let's put our non-carbon substituents. Well, we know on carbon 4 we had an OH, right? We know we had an OH, but when we go through the cut backwards, we're going to get a carbonyl. So we had our OH, and it now turns into a carbonyl, and I'm just going to put an H there. Okay. Remember, you can't write a synthesis with the carbonyl cut step as literally R1, R2. You actually have to fill in the R groups. So the R groups can either be hydrogens, like it could have been 2 hydrogens, or an alkyl group, depending on how you're actually cutting. Okay, and so we have our carbonyl. I'm just going to move this. And on the other carbon that we cut, we put a lithium. And so let's count our number of carbons, because we need 4 carbons or less. You can see that the carbonyl one has 1, 2, 3, 4, 5. So that's not good because they wanted us to have 4 or less. If you knew the reaction here in red, you could have continued this question backwards and you could have cut this down, but because we don't know that, or at least you guys don't know that reaction yet, we cannot continue the synthesis. Eventually you will be able to, right? But you can't do it now. All right? And also remember, if we were to do the synthesis, we should still always number our reagents. So I'm just going to put this number 1 to some sort of like proton source, so H2O. Right? And yeah, but again, we're not going to go the red route. So let's try the blue. I'm going to erase this. Okay, so now we're going to cut between 4 and 5. So again, let's draw everything out. And always number. 1, 2, 3, 4. 5. Okay, and now we're doing this piece. 5, 6, 7, 8. Always a good idea to number. Don't get it in your head that you may always know how to do it, because it's very, very easy to lose just 1 carbon, and that can mean the difference between getting 100 on a test or getting points off on a synthesis for kind of a silly mistake. Okay, so we have all our carbons numbered. Now let's put our non-carbon stuff. We cut between 4 and 5, so that's good. We don't have a bond there anymore. Carbon 4, we had an OH, but remember, when we do the cut going backwards, that OH now becomes a carbonyl. So I'm just going to erase the H, double bond, and I'm just going to put an H there to make it look a little better. And on carbon 5, we now put a lithium. Okay? And so if we count all of our carbons, all of our compounds have 4 carbons or less. So that's perfect. And so what I'm just going to do is draw an arrow so we can now number our steps, right? So step 1, I'm going to put the carbonyl. That looks really ugly just because it's kind of cluttered everywhere, but you guys get the idea. And then step 2, I'm just going to put H2O. And now we're going to put that. All right? And you would be done with your synthesis here. Yeah, and also you could, I've mentioned it before, but you could have definitely seen this on the synthesis where instead of the carbonyl group being up there in step 1, you could have the lithium in step 1. It's fully interchangeable, okay? It may be easier to put which one over the arrow depending on if you can continue the synthesis, as in the one that is not cut down enough, you kind of want it to be where the carbonyl is right now, right? Because then you could keep working on it, kind of, right? And another way you could do it is you could, instead of having that number 1 above your arrow, let's actually just bring that back. What you could do is just take the lithium, put them together plus, right, and just do like plus whatever the two reagents are, and then step 2 is H2O. They'll understand. All right. And so I hope this synthesis made sense to you guys, and it gave you an example of how you can use alkene reactions in your synthesis. Okay, so do not get into the mindset that essentially it's toolbox and only toolbox. That's an easy trap, and then inevitably when you're going to sit for your test and you get a synthesis question that looks completely out of nowhere in terms of not on the toolbox, well, then you might not know what to do. And they do get harder with every exam, especially when you go into Orgo 2, when the synthesis questions can incorporate a bunch of different reactions. Okay, and so my advice, know your reactions forwards and backwards, especially backwards. All right, it'll be much more beneficial to you if you understand them backwards, because it can make your synthesis much easier. All right, and you won't have to be there stressing about one synthesis question. Okay, and so if something here didn't make sense, please feel free to email me. Go to the TAs at the CLC. If you're watching this on YouTube, please feel free to comment any questions you have. That way others, in case they are confused, may also, and who also have that same question, I can answer it right there for everyone, right? And I will see you guys in the next video.